In a hose, we can control the flow of water by pinching, attaching objects, or making knots. In cord UIs, we use the same interactions to control the flow of electricity through everyday cords. By using a sensor-augmented cord that can detect its shape, we can use a knot to dim a light, or switch it off completely. This simple interaction could be used to control almost any other variable. It is also a physical embodiment of that variable's state. Ideally, we could move the switch anywhere along the cord to a different position. Or we could control the color of a light bulb with multiple knots. Using capacitive sensing, we can temporarily mute and pause the music by pinching the headphone cord. And releasing it will resume playback. This can be useful to quickly listen to in-flight announcements or your cab driver. You could attach a binder clip to this pressure-sensing power cord to put the computer into sleep mode. Removing it will wake it back up. We can also use other objects. Using this special piezoelectric cable, we can switch the power strip on or off with a quick bend. The whole cable acts as a switch. This hard drive with a special stretchable cord and stretch sensor lets us safely eject the disk from the computer by softly tugging on it before fully disconnecting it. Cord UIs, controlling devices with augmented cables.
What if materials could defy gravity so that we could leave them in mid-air? Zeron is a physical and digital interaction element that floats and moves in space by computer-controlled magnetic levitation. Both the computer and people can move the Zeron in 3D space. Zeron's movements can be digitally manipulated. For example, the human gestures can be played back or rescaled in a physical form. A complex physics system, such as a three-body problem, can be simulated in front of you as a physical reality. It lets you directly put your hand into this 3D simulation space to manipulate its configuration in a tangible way. You can also change the orbit of a revolving planet, which will then change the velocity, confirming Kepler's law. Using the Zeron as a sun, you can simulate lighting of your own world on a small scale. Or create 3D camera paths for rendering virtual scenes of architectural models using Zeron as a camera. When you draw a 3D path in the air and release the Zeron, it is sent back to its initial position and then moved along the previously recorded 3D trajectory. A Hall sensor measures the position of Zeron every few milliseconds, and the electromagnet repels or attracts Zeron based on their distance. This levitator is being carried by the 3D mechanical actuator. The position of the Zeron and the user's hand is sensed by infrared stereo cameras that we built out of conventional webcams. Together, these components create small space without gravity. Even after user moves the Zeron to a different position, the system can restabilize and keep the Zeron suspended. Our body and mind have developed great capacities for understanding and manipulating physical environments. And our long-term vision is to embed computation in physical materials that can directly interact with us. In this way, we seek to redefine the relationships humans have with materials, space, and digital information.